The next statistical tool that we are going to discuss are the linear regression and correlation. These statistical tools used for hypothesis testing, describing the closeness of the association, and drawing a line through the points, the correlation and linear regression. When investigating the relationship between two or more numeric variables, it is important to know the difference between correlation and regression. The similarities, differences, and disadvantages of these tools will be discussed in the next slide. Linear regression analysis. Regression analysis is an important statistical method for the analysis of medical data. It enables the identification and characterization of relationships among multiple factors. It also enables the identification of prognostically relevant risk factors and the calculation of risk scores for individual prognostication. The purpose of statistical evaluation of medical data is often to describe relationships between two variables or among several variables. For example, one would like to know not just whether patients have high blood pressure, but also whether the likelihood of having high blood pressure is influenced by factors such as age and weight. The variable to be explained here is blood pressure, and it is called the dependent variable, or alternatively, the response variable. The variables that explains it, the age and weight, are called independent variables or predictor variables. Measures of association provide an initial impression of the extent of statistical dependence between variables. If the dependent and independent variables are continuous, as is the case for blood pressure and weight, then a correlation coefficient can be calculated as a measure of the strength of the relationship between them. And we have two types of linear regression analysis. The Spearman's coefficient that describes a monotone relationship wherein a relationship, one variable, or the dependent variable either rises or sinks continuously as the independent variable rises. The next one is Pearson's correlation coefficient. This describes a linear relationship. In terms of interpretation or meaning, correlation coefficients provide information about the strength and direction of a relationship between two continuous variables. But there's no distinction between the explaining variable and the variable to be explained is necessary. For R equals 1, perfect linear and monotone relationship is expected. The closer R is to 1 or negative 1, the stronger the relationship. When R is equals to 0, it means no linear or monotone relationship. When R is less than 0, negative, or an inverse relationship, high values of one variable tend to occur together with low values of the other variable. When R is greater than 0, there is positive relationship, where high values of one variable tend to occur together with high values of the other variable. Graphical representation of a linear relationship. Regression analysis is a type of statistical evaluation that enables three things. It can describe relationship among dependent variables, and the independent variables can be statistically described by means of regression analysis. It can also do estimation. The values of the dependent variables can be estimated from the observed values of the independent variables using graphical representation. The third one is prognostication. The risk factors that influence the outcome can be identified, and individual prognosis can be determined. Hence, a negative relationship is represented by a falling regression line or a regression coefficient of r less than 0, and a positive one is a rising regression line with an r that is greater than 0. Here are the different regression models. We have linear regression, logistic regression, proportional hazard regression, and Poisson regression. The most simple one is the linear regression that talks about description of a linear relationship. Simple linear regression is similar to correlation in that the purpose is to measure to what extent there is a linear relationship between two variables. The major difference between the two is that correlation makes no distinction between independent and dependent variable, while linear regression does. In particular, the purpose of linear regression is to predict the value of the dependent variable based upon the values of one or more independent variables. Evaluate the strength of a relationship between two quantitative variables. A high correlation means that two or more variables have a strong relationship with each other, while a weak correlation means that the variables are hardly related. Correlation analysis, in other words, is the process of studying the strength of relationship of available statistical data. This technique is strictly connected to the linear regression analysis, that is, a statistical approach for modeling the association between a dependent variable called response and one or more explanatory or independent variable. These are examples of high correlation and low correlation events. High correlation, example, caloric intake and weight, eye color and relatives' eye colors, amount of your time in studying, and GPA. However, on the other side, low correlation, example, is sexual preference with the type of cereal you eat, a dog's name and the type of dog biscuit they prefer, and cost of car wash and how long it takes to buy a soda inside the station. Correlations are useful because if you can find out what relationship variables have, you can make predictions about future behavior. Knowing what the future holds is very important in the social sciences like government and healthcare. Business also use the statistics for budgets and business plans. The correlation coefficient is a way to put a value to the relationship. Correlation coefficients have a value between -1 and +1. A zero means there is no relationship between the variables at all, while -1 or +1, that means there's perfect or negative correlation. Negative correlation means inversely proportional, while positive correlation means directly proportional. Correlation is not equal to causation. While a significant relationship may be identified by correlation analysis techniques, correlation does not imply causation. The cause cannot be determined by the analysis, nor should this conclusion be attempted. The significant relationship implies that there is more to understand and that there are extraneous or underlying factors that should be explored further in order to search for a cause. While it is possible that a causal relationship exists, it would be remiss of any researcher to use the correlation result as proof of this existence.